Hi guys, in this video I want to walk through this LeetCode number 100 same tree. So we are given the roots of two binary tree P and Q, and we need to write a function to check if they are the same or not. Two binary trees are considered the same if they have the same structure, and also the values are the same. So let's take a look at some examples. Look at these trees. These two trees, they are identical because they have the same structure. Also, the values are the same. That's why the function outputs a true. And for this one, they have the same value, but they're different structure because, as you can see, the right child node for this tree is none, and the left child node for this tree is a none. So in that case, they are false. As you can see, the convention is printing the root nodes, and then the left child node, and then the right child node. In this case, the left child node is a none, right child node is a true. That's why they is not the same, because the structure is not the same. For this one, as you can see, the value are not the same. For this trio here, the left node has a number of 2, and the right node is number 1. For this node, it's the other way around. That's why the number is not the same. It's not the same tree. So we will solve this question by using a recursive function using Python. Let's take a look at the code. Whenever I start with recursion, I always start with the return statement and then work my way up, because I know that in order for a tree to be the same, the left node of one tree must equal to it's the same as the left node of another tree. That's one of the conditions, and another condition would be the right node of one tree must be the same as the right node of another tree, and then we recursively checking. And when this statement is called, as you can see, the p dot left and then q dot left, and then become the new p and q, and the same as this one. So we have the and in here because we're going to make sure that in order to return the true, both these two statements has to be satisfied. That's why we need a and for the logical operator. And after we have this return statement written properly, we can work on other conditions to make sure that we return the correct Boolean output. And so this is the few conditions for based on the example that we walked through, and the values have to be the same on the node. If the value is not the same, no need to execute this part. Automatically return the false. And if both nodes are empty, so they are identical, so return a true, and the rest will not be executed. So that's the situation in here, right? So for this one, for example, the left child node and the right child node for this particular two, they are none, which is the same as this one. The left child node and the right child node will be the none. So both of them, when they compare, didn't draw in here, but you can see that their children, both of them, they are none, and both of the left and child will return a true in here. And this is another condition where one of the node is not none and another one is a none, and this one will return a false. And this is the situation in here. For example, the left child node is not none, and the left child node in here for this tree is a none, and they will return a false. And same for this one, the right child node is not none, is a none, and then the right child node is not none, and this is the condition in here, and they will return a false as well. So after we capture these conditions, and then we recursively call the function itself, and then we will return in the root node. We go all the way up to the root node, and then we know that this is the two trees are identical or not. In terms of time complexity, is big O of n being the number of nodes, because we recursively calling the function itself n time when we traverse down all the children. In terms of space complexity, is big. The best case will be the big O of log of n. If the two trees are balanced, it will be big O of big N. In the case where is the worst case scenario, where it's completely unbalanced, meaning that either the trees have all the left node, if P has only left node and Q has only left node, or the P has only the right node and the Q has only right node, and then we need to keep a recursion stack. For example, if we only have this one node and then this one and this one is all none. So this is the space complexity, and this is my solution. And in terms of performance, as you can see, 16 milliseconds is faster than 77% of the submission, and so it's pretty fast and scalable. And this is my solution. I hope you like it. If you do, please help the algorithm by pressing the like button and also subscribe to the channel. And I will see you in the next video. See you. Bye-bye.